Hello and welcome back to the Jolly Franchers YouTube channel. I'm James Franch and I am the solo developer on a video game called Kid Detective, which is a murder mystery RPG, and it's going great. Major milestones are being reached. This week we'll be animating our top-down character for our RPG using only visual scripting. And it was really easy, to be frank. So I hope you enjoyed this. I will also be giving a tip for how to make your pixel art look clear and crisp in Unity near the end of the video. And at the beginning, I'll also show my C# script for people who just want to do player movement using code. So whatever the case, we're gonna learn a lot, and next week we'll start working on some of the RPG mechanics. So I very much hope you enjoy. Okay, so now let's move on to Fungus. We have a new block that we called Animate Player. We know how to create a new block, right-click. And we only need one variable this time, which is an Animator variable. And technically, we have yet to create that, even though secretly I have. So you can go ahead and either you can have an animation window open by clicking these three dots, Add Tab, Animation, or going over here to Window and doing the same. And we are also going to need an Animator window. Now, usually if you have a new game object, like your player, it'll say to begin animating main camera, create an animator or an animation clip. So you can go ahead and do that with the player. And you'll notice you have an animator window that has any state, entry, and exit in it, but it does not have these two blocks yet, or these parameters. The first thing we're going to want to do is create these parameters. We are going to want to go up here to the plus button and add a float, and we'll call it movement X. And we're going to want to create another float and call it movement Y. And then we're going to create a bool and name it moving. And that will keep track of whether our player is moving or not between our idle state and our walk state. Don't worry about this blend state yet. It will automatically appear when we do something later. So let's go back to our flowchart. We are going to implement these numbers so that our animator knows whether we're moving right or left on the x-axis or up and down on the y-axis, or whether we're moving or not. First of all, in our update method, we are going to want to, just like we called the move player block and the wait until finish call mode, we are going to do the same thing with the animate player block. Very important that you wait until the animating is finished. And the call command is here under flow, just like it was last time. And now here in the animate player block, it will be very simple. We are going to go to flow and do an if command. And if our movement vector 2 is not equal to 0, 0, which basically means if we are moving, because our movement vector 2 is what actually sets the player's velocity. So if we are moving, then we're going to set anim float. You can go up here to animation and have the set anim float command. And this is where we want an animator. So I went ahead and created an animator variable right here, and I dragged in the player game object, which because we created an animator, we can go ahead and drag in there because it has one. And so now over here, if you click this arrow on the right, you can click your player animator. Of course, you can just have a value instead and drag the player in. But you'll have to do that on all of these, so if you want to change the animator for whatever reason, you'd have to go into all of these commands and drag in a new one. So in case you want to change the animator later, this is just a good practice for making it easy on yourself to change things later. And we are going to set the parameter name in the animator, which has to be spelled exactly like this parameter here, we are going to change movement, capital X, to our variable movement X, which we already have created from last time. And we are going to do that exact same thing with the movement Y parameter and the movement Y variable that we created last time. Once again, it's a set anim float command and the player anim animator. We are going to want our animator to know that we are indeed moving because our movement vector is not 0, 0. So we're going to do a set anim bool command. As you might guess, it's an animation right here. And we are going to set the parameter name, lowercase moving, to true because we're moving. And then we're going to want an else command, which is also in flow. And we're also going to want an end command to end this whole if statement. And we're going to want another set anim bool command. You can even just duplicate this one by clicking this button and dragging it down into your else statement. And then you're going to change if we are moving. If we're not still, we are going to do these animation commands. And if we are still, then we are going to set moving to 0. And we're not going to set these floats to anything different. We'll see it in practice, but it's because you want to know which direction you were moving when the player stops. You don't want to keep updating that so the player just faces downwards, which is 0, 0. You want the player to idle in the direction you were walking already. So that's why we don't update these two. And you'll see why. You don't have to really understand that right now. Let's look at the actual animations for the player and how you animate things. Now, I've done this before in my Monkey Island tutorial. I did 8-way animations. As you can see, there are 8 different directions for idle animations and 8 for the walking animations. So I've shown this before, but I'll go over very briefly what I did. So here's our player game object, which at the moment is a giant circle from last time. I believe I had the circle set to 1 on the x-axis and 1.5 on the y. You can go ahead and set that to 1, 1 to just set your sprite to its regular size. I'll probably do that. I might do 2, 2. You can do either. And you can go ahead and set this base sprite to, your player, just so that you can see the size of your player, but it actually doesn't matter. You could keep it a circle, because when we play our animation, there's our player idling down. What I did is I dragged in a sprite sheet, and we can take a look here in the inspector. This is my sprite sheet of different directions. I have a few of them. You have to go in here to the inspector, and you want to set the sprite mode to multiple, because we have multiple different sprites we want to chop out from the sprite sheet. If you're using pixel art, which I'm going to, because obviously Earthbound, Pokemon, all that pixel art, you're going to want to choose point no filter, so it's not blurry. It shows the sharp edges of the pixel, and you're going to want no compression. Pixels per unit is important. You want all of your pixels per unit for all of your sprite sheets to be exactly the same. In my case, I've just been using 100, but something like Pokemon uses 16 by 16 tiles for the whole thing, so you might want to change it to 16 or 32 if you're using, tiles to keep things organized. It'll also be bigger. The actual objects will be bigger in Unity space, which is actually pretty helpful, but I've always worked with 100 pixels per unit. So it's really up to you. Just use the same pixels per unit. I've gone into detail about that in my sorting order video in the Monkey Island series. So if you want to know more about pixels per unit, go there. And then you can go up here and choose slice. Now I chose bottom so that my sprite's pivot point for my sprites would be on the bottom. So you can go ahead and press slice here, but I'm not going to because I already did. Then you're going to want to click on one of your sprites. And because this is pixel perfect, you are going to want to check whether you have 0.5 pixels here. And if you do have, say, 8.5 pixel, if your sprite is not an even number of pixels, you can go down here and change it so that your sprite operates around the middle of it. Just trust me, it's better if you do it from the bottom center of your character. If you do it over here, when you animate your sprites, if you didn't make your sprites all the exact same width, see this one is 17 and this one is 18. So if I made all my sprites 18, or I dragged out this box to where it was 18 width, then you could get away with, having a pivot point at just 0, 0. Play with the pivot point to get it to look how you want. And you're probably going to want it to be an even, not a decimal point level of pixels, so that your pixels show up nice and clear in game. And for your animations, you are going to want to click here. You're not going to have anything in this list, and go ahead and create a new clip. You'll probably want to make a new folder by right-clicking, going to New, and choosing Folder. I made a new folder named Animations, and then I made a folder called Player Animations, and then I went ahead and made new animations in here. And you can name the new animation here. They each have to be named something different. So make sure all of your animations have a different name than one another, or your game will get confused. So let's just do player idle down as our first animation. And you'll do this for each one of your animations. I have player idle down left, down right, left, right, up, left, up, right, etc. And then I have player walk all of those directions as well. For the idle ones, it's easy. Just drag in the sprite of the direction that your player is facing. You just drag it in from the project tab here, which wherever your project window is, or you can go up here and you can add a project window. This just makes it easier to animate. You can also drag your animation window somewhere else. You just drag in the sprite for your animation, and then if you want to play it, it's going to be weird because I dragged in a random sprite, but that's how you play your animation. And the walk animations are pretty easy. In general, if you're just looking for a little animation tutorial, you're going to want to start a walk animation with the player's foot moving, so that the player feels like they're moving immediately, taking a step as soon as they want to take a step. Then you're going to go to together. You're going to want, when your player's not taking a step, you're going to want them to be a little bit taller, so that when they're taking a step, they're bending their legs just like a person does. And then here, you're going to want to put 2 still animations, like with your player's legs together, because if you don't, I'll go ahead and delete this one, then it's going to look a little bit jerky because the animator goes directly back as soon as it reaches this, and so you won't have a moment when your player's legs are together here, really. It'll instantly go back to here. That's why you want 2 of those. And go ahead and do exactly that for all 8 directions. Okay, once you've done that, you're going to want to step into the Animator window. Now, all of your animations are going to be displayed here in a diagonal line. You can go ahead and delete all of those, or you can drag them to the side. It doesn't matter. We're not going to use them. We are going to right-click in the Animator, create state, and we're going to create from new blend tree. And I'll just show you what that looks like. Bring up the inspector on the right here, and you're going to have something called blend tree, and we're going to name the first blend tree idle. Okay, here's my idle blend tree. Go ahead and double click on it, and in your blend tree, I'll go ahead and do it with a blank one so you can see what it's like when you arrive. So here in your blend tree, you're going to have one node, and it's going to be called blend tree. We're going to want to go up here and click 2D simple directional, because we want to use both our movement X and our movement Y values to tell our player which way to animate. And then you're going to go here to the plus button and add a motion field. Now, when our X and Y values are certain things, our player will move in certain directions or animate in certain positions. And as you can see in my blend tree, these are the different directions, the different values. You can see them represented here that we're going to move in. And I can even just show you what the animator looks like as I move my player different directions. Voila. You can see how the numbers change to represent which direction we're moving. So that's why we input the numbers we do here. When our movement is -1, our player will look like they're going down. When our movement is only 1 on the y-axis, our player will look like they're going up, and vice versa for all of the directions. So great, we have that. I know my player's not walking right now, not showing the walk animations, and yours probably isn't either. Now, go back to your base layer. When you're in the blend tree, you can see base layer up here. You'll only have an idle block, so you're going to want to right-click, copy, and paste your idle block, and we can use it exactly for the walk block, Retitle it walk or moving, whatever you want. Double-click, we'll step in here, and it has all the idle animations, so you're just going to want to go in here and replace those one by one with the corresponding walk direction, like so. Once you have done all of that, all we have to do is make the transitions from idle to walking. So go back here to the base layer, and on your idle block, you are going to right-click and make a transition like so, and you're going to click on the walk block, and it should attach, like so. Then you can click on that arrow right here. So this is the idle to walk state. So if we are going from still to walking, we are going to want the variable moving to be true. The way you add one of these conditions is you press the plus button, and then you can go ahead and select the variable you want. And we are going to want moving to be true. We're going to want to check off exit time up here and make sure the transition duration is 0. So we go right from walking as soon as we press the button, and there's no transition time. Same thing with walk to idle. We are going to right-click, make transition, put it back to idle, and we're going to want to add the condition when moving is false. We're going to go back to idling, click off exit time once again, and make sure the transition duration is 0. And now we can play and see it in action. Voila! Look at that. Look at us go. When we're walking, we stop in the direction we're walking, we idle in that direction. Now, it may have a little trouble with the diagonals because, especially on a computer, you're pressing 2 buttons at the same time, and so you're going to release one before the other in most cases. So the player's not going to want to stop in their diagonal position. And that's something that I've found a way to address before, so I can do that if you all really want that. But this is a pretty polished thing that most games would take. That's that, really. Now, your pixels may look blurry and distorted, like this. As you can see, my player is much farther away now, and when we zoom in on them, the pixel art is not looking quite right. As we can see, when we move around, it changes. Now she looks really sleepy. And you can see our pixel art looks like it's changing, and it's blurry, and it's weird. So how you're going to want to get around that, you're going to want to go to Window and click on Package Manager. And as you can see, here's the 2D pixel perfect package. If you don't see it here, then you might want to go up here and click on all packages. If you still don't see it, you're going to want to also show preview packages. And it's going to give you this warning, but I assure you the pixel perfect package works very nicely. You'll probably want to download the latest version, and you can just go ahead and download it or any of these other awesome free tools down here. And once you have, go to your main camera, go to add component, type in PI, and add your pixel perfect camera. I'll go ahead and I'll drag in a little background to the scene. You're going to want to make sure your player's sorting layer is above your background. And you can go ahead and play with what your pixel perfect camera looks like. You can give it a border either on the Y or the X axis like a lot of old games do. Mess with these different settings. As you can see, if I don't upscale the render texture, my art starts looking a little bit blurrier and changing around a little bit. As you can see, the art looks pretty perfect here. It is displaying well. You could also do pixel snapping, which will snap your pixel art to the reference resolution of your choosing. You can basically type in any number and change it around. See what you like. As you can see, it's going to act a little bit funky if you do this while you're playing the game. Make sure you know that it will not save what you do here after you exit play mode. So you can go ahead and copy the component and paste in the values after you exit play mode. So yeah, that is how we're going to make this game look a little nicer as we build the mechanics next time. Okay, that was the video. Next time we will work on more RPG mechanics. Maybe even start turn-based combat? So we'll see. We'll see what I come up with. And if you're enjoying this video, if you want to support the creation of this RPG tutorial using visual scripting and the forwarding of Fungus tutorialization to the future game devs. Because Fungus is taught in colleges and schools, but I don't see that information out on YouTube very often. So that's what I'm doing here. And if you want to support what I'm doing, please leave a like and leave a nice comment and subscribe and tell your friends and make a video game with them. Okay, until next time, stay jolly.